Now let's turn our attention to something that's a bit more familiar, the demand curve. You know from intro econ that demand describes the relationship between price and consumption. So here what we want to do is the same thing, taking our demand equation based on a standard Cobb-Douglas utility function. Let's look at how consumption changes with price by taking the derivative of x, our optimal x, with respect to the price of x. So again, looking at this equation, right, all I'm doing is taking the partial derivative with respect to px. You see it's in the denominator, so I could rewrite this as alpha over alpha plus beta times I times px to the -1. So when I take the derivative, what I get is -1 times all these things that I'm holding constant. And then times px to the -2, right? So I could rewrite that as I over px squared. Now, just like before, what we want to do is think about whether or not this is positive or negative, so we know whether consumption is increasing or decreasing with price. Here, right, my alphas and my betas are positive, my income is always positive, my prices are positive, and it's squared anyway. So this segment here is all positive. And then I've got this -1, which of course is negative. So this is all going to be less than 0, telling me that I have an inverse relationship between price and consumption, which you knew already because demand is downward sloping, right? When the price goes up, you are going to buy less. And we can see that by looking at the effect of a price change on our optimal consumption bundle. Notice that when we looked at the income consumption path, we were shifting the budget line out parallel, right? Because that's what happens to the budget line as income increases. But here we have a change in price, and specifically we have a change in the price of good X. So what's happening here is that we have this budget constraint 1, budget constraint 2, budget constraint 3, and as we're shifting the budget constraint, you can see the price of X is decreasing, right? I can afford more X as we go from 1 to 2 and then 2 to 3. So here we have a decrease in the price of X. How does that affect the optimal consumption of X? And why? And if I look for these tangencies here, I see that what's happening, this should be a straight line here actually. What's happening is that no matter what the price of X, my consumption of Y doesn't change. And you can see that based on the Cobb-Douglas demand curves, right? The demand for X does not depend on PY. There's no PY in this equation, and likewise demand for Y does not depend on the price of X. So as the price of X changes here, my consumption of Y remains constant, and that's specific to Cobb-Douglas utility. And what happens to consumption of X as the price decreases? My budget constraint shifts out, becoming flatter along the x-axis, and my consumption of X increases. So the change in the price of X has no effect on the optimal consumption of Y, but consumption of X increases. And we can show that relationship as a demand curve right now, not thinking at all about y, but just looking at the relationship between px and x. So I've got px on the y-axis, x on the x-axis, and I can see as price of x decreases, consumption of x goes up. And that's what our demand curve would look like. Now, in your intro classes, demand was always linear, but here, demand does not need to be linear, and for Cobb-Douglas, it's not linear. So, we don't have a straight line, and that changes some of our assumptions about, what is the elasticity of demand and what does it mean to move along the demand curve. But we'll get to that in a little bit.